Wen Chu. Wen Chu actually a co-founder of a cat company, and he sold the company to a bigger cat company. But at home, he still, cannot stop his maker's spirit, and he built many things by himself. Let welcome Wen go on stage and show his projects.
Okay. Last week I was in a talk given by Professor Ming Li from CMU about topic on machine learning, and he asked a question: what's the difference between a scientist and an engineer? And one of his students answered, Professor Li, you are a scientist, and as for the engineer, is a scientist who actually makes some money. But to me, I think the answer to me is the engineer is the scientist, but he has to make a product, actually deliver a product under the time limit, under the budget limit. And so that's my definition, and I think that would be fun for me to be an engineer for the whole time. And I'm going to present two projects I did this couple months ago. And I use the Arduino all the time. And because one reason is because Arduino is cheap, and all the supporting is good, all the ecosystem is good, and you can find many help, and you can find many code samples. For example, I got this set of sensor 37 pieces for around $30. So that's one reason I choose the Arduino. And these four Arduino boards I got it. It's about the same price that I got 30 years ago for the Z80. So I think that's a good deal. And by the way, for many of today's presenters talking about the chip connected with the Wi-Fi, I have one in my hand. This one less than $10, and you can use this one to build a router. Also, the hacker actually use this guy to make a fake Wi-Fi spot, and they put into a coffee shop, smart whatever, then to pretend to be that shop, so he can collect information. It's just under $10. So, engineer always carry a microcontroller in his pocket. The first one I'm going to present is the remote control robot, which is popular project for the students, which they use for the competition. And I add a I add an IR remote control. Also, I add a camera pen here assistant to it. And because my original design is to make this tower as the laser gun toy. The second one I made is people can say it's a PM2.510, but basically it's just a air dust sensor. And I integrate with the temperature and humidity and the air pressure barometer and a Bluetooth client to talk to a cell phone. Simon suggests to add a mini tutorial for using Arduino, because people might not be able to use it. So at least I used one very simple example. You can download the Arduino IDE, the interface, the UI GUI. Then over there are a lot of base examples. The very basic one is a 0.1, the blink. You can just upload it to your Arduino, then it will blink, then that's it, you finish it. In every Arduino program, we call it a sketch. And there are two functions. You got to have these two functions. One is called setup, one is a loop. The setup will run once. Basically, you do this to do initial condition. The loop will continue to run. So you can use this loop to monitor something like that, a sensor or doing the DC motor control. And there are digital pin, also analog pin. For digital pin, you can do a read and write. You can send a path to control or emulate the analog signal. and there are analog pins. Analog pin inside, there are analog ADC is analog to digital converter. By the way, a big difference between the Raspberry Pi and Arduino is that Raspberry Pi doesn't have an AD controller. Even it's much more powerful, but for the sensor usage, it's not like friendly. And this is a Blink. It's very simple. It comes with a setup and loop. You specify which pin you're going to do what. Then you go in the loop to turn on the LED for one second and turn off the LED for 1 second. So you got your first program running. It's very simple. It took me about 1 month to go to this step because I have to collect information, buy the chip from Shenzhen, and wait for 1 month to get everything. And in the interface, one thing you need to do is you have to specify what kind of Arduino, because there are so many Arduino Nano, Mega, Uno, whatever, a lot. Select the type, the CPU type. Because every CPU is kind of different. The internal memory size and configuration speed is different. So you tell what kind of CPU you're going to use. And what's the connection, the USB cable. And just load it, and compile and load, then that's it. This is my 2-minute tutorial. And for this robot, and something that we need to take care, we need to be very careful when you build a robot together is the VDD always connect to VDD, the ground always connect to the ground. If you swap it, it might burn your something, you burn your Arduino or burn something. But there are sometimes there are some conditions, some purpose. For example, if people use the switch to emulate the motor control, they call crossover H bridge. So the motor can turn clockwise and counterclockwise. Probably this is the only condition you cross over the VDD and ground. But this is one of my experiences that I spent two days to debug one of my projects. It turned out, because I actually swapped the 2 pins, I didn't see it, so DC never worked. But luckily, the board has a protector, so it does just shut down. But it took me 2 days to figure it out. And to build a robot is simple. You can get a kit and you can put it together very fast. But you can download the software from somewhere and just install it and run it. But the difficulty is how to make it work as you expected. For example, you can build a robot can work, but no problem. But how to make it run, how to make it when you fall down, how to get up, it's very difficult. And you can spend $1 million for this kind of algorithm. But this is just starting point. Oh, sorry, wrong place. And this is the first, this is the one of the robot I created. I follow some guideline from this book, and if you just go through it, you can get everything go very fast, but probably it won't work in your setup, because as I said, every robot is different depending on different speed or rotor speed controller. You need to fine-tune it, but at least this is a good starting point. So pretty much I have everything. I have a pin, the sonar sensor. I have a microcontroller. I have a battery pack, 2 battery packs. The one in the front is the cell phone charger. I use to drive the Lenovo, to drive the Arduino. And there's the mini pen and tilt system on top of a channel. And the purple thing is the laser gun. I eventually put it in. I try to control with the mini helicopter IR controller. Also use the TV remote control. So both TV remote works much better because the signal is stable. The IR chip tool is quite cheap, so signal is not good. But you can try everything. This is the fun part of it. You can try everything. And here is some introduction for the DC motor and for the servo. The DC motor, you can see that Usually we use something called the H bridge. H bridge is the current can go either clockwise or counterclockwise, so the motor will go like either way. This is called a DC controller. The servo use the path to control, depending on the width of the path. So the servo can go to 0 degrees, 90 degrees, or 100 degrees. And before I actually purchased the servo, I don't know there are so many knowledge involved with the servo. There are digital servo, analog servo, how to control the torque, and the bearing structure, whatever, and whether it's waterproof. So a lot of things to learn. But basically, this is what you need to know the difference between this motor and the servo. In order to keep the signal as precise as possible and involve a lot of thinking. So even you got a library here and there, if they put them together, it might conflict. So you'll destroy your timing. And also the noise generated from the DC motor might destroy your timing. So a lot of things is very interesting to do. For the pin sonar, you can find a 3-pin version, 4-pin version, 7-pin version, different price. Basically, the theory is the same. The pin send down the high frequency pulse, and when we get back and echo back, and a receiver to time the difference between the time when we send it and I receive it, so to calculate the differences. By the way, this is good to teach your kids about some scientific because it's very fun. And I bought many different servers for different purposes. A tiny one for the tiny pen and tail system, and DC motor to drive the wheel. Some DC motor is very, very expensive, but very reliable and run very fast. So depending on your need. And some issue I found is, as I mentioned before, the servo now always go from 0 to 180. Sometimes it's your fault because you copy some code from some place which you didn't start it. You need to modify. Sometimes it's because the servo you purchased is too cheap, and the noise can affect the timing. Sometimes it's because your software integrate together, they conflict, so you have to resolve yourself. But I built, and then for this project, I used 3 different ways to control the servo. One is use interrupt, one is use timer, one is just by counting. And so different purposes, I use different library. But for usually, normally you don't need this kind of problem. And this is the kind of like a documentation for my wire diagram. It's a free program called Freeze, and I can document how I connect the wire, and so next time I won't get loose. And this tool can also convert your final design to a PCB. You can send to a PCB manufacturer, give you a PCB so you don't have this jumper wire going all around. After I got the first one, then first one working, then what's the second one? Second one is to make it talk to the first one. If I plan to make the second one to follow the first one step, but keep some machine learning capability, also some vision to watch the distance, to keep track of distance from the first one, the second one. There are different ways to do communication between these kind of robots. People use the IR wireless or use the camera with some sign, and use a radio signal and laser with encoded signal. And some creative ways use the pin sensor I mentioned before. Because the pin sensor, you have a receiver, you have a sender. So people rewrite the protocol to make them as a communication tool. And this is the second version I built, but not quite finished, but it looks much better than the first one. And after I built it, and I found out this is very good because I like to do a photography, and so I like to use this one to control the flash. The flash can go around and change the direction. So, yeah. The second project is the air dust measure. I have a air dust sensor and Bluetooth module and air pressure and temperature sensor and LCD altogether. And this is the parts I use. Because the size limitations, I use another Arduino. It's called Nano. And the LCD, we call it Nokia 5110. It's recycled from the Nokia phone. And it comes with the internal buffer. And most of the program use the buffer to represent every bit. So it took 1/4 of all the memory I got on this Nano chip. And for the air dust sensor is from the shop. One thing for the sensor experience is that the sensor not normally like digital, it's nonlinear, so we had to do some adjustment. And since I have a Bluetooth, I make it work, and this is my cell phone's screenshot. I send the information to my cell phone. You can get it for this kind of application for free, and you can write your own one. And basically, I also have an air pressure sensor, but because after I put this in and exceeds my memory budget, so I took it out. And again, this is the Y diagram. This one is more complicated. And one lesson I learned is that one of the Mega 2560, I bought it doesn't work. And I thought it's broken, but it turned out it's something called a bootloader. Bootloader is the program which you load out the program. Load out the program you wrote to the system. And so I do some study and try to flush this bootloader. There are different ways. You can buy the programmer or you can build yourself. So I built myself. This is a link how I do it. And if you guys see similar problem, and you can follow this kind of instruction. There are many ways people suggest to do it, but most of them doesn't work. So you have to try your luck. And there are some books I suggested, and you can start it. And I have seen many of Arduino books, and this file I think is very good for starting point. And the one on the center is very useful for debugging. And there's some idea where you can get idea. Most of the idea I got it from the instructor.com. This is a good place to start. And the CAD software, and you can get most of them for free to create your PCB layout and send to a PCB manufacturer. You can also do a virtual system modeling, kind of like put a PCB in your system. And this is where to find the bugs. Most of best place to find the parts is from Adafruit. They got best support. And most cheap one is from DS.com, it's from Shenzhen. But the shipping, it takes 1 month to 3 months, so it's a trade-off. This is part list just for your reference. And this is the CAD I mentioned. You can get it for free or pay a little bit money. You can get a lot of help. And the tools you need some tool and soldering. And this is a crimping. I think this is very useful because you got to do a prototyping. Sometimes you need some special lens, and you got to know how to do this, and it'll help you a lot. And that's it. Thank you.
Thank you.
Thank you.
Bring
Thank
so
you.
much information, and with his presentation, you can build your own project.
Yeah.
So let's present a small token to thank your effort to put the